Let's take a look at the infrastructure virtualization capabilities of UCS. Now remember, I said in the first video that UCS is really a single integrated system of switches, cables, adapters, and servers all tied together under a single common management umbrella. And one capability that really makes all of this happen is the ability to virtualize every component of the system at every level. So switch port virtualization, cable virtualization, adapter virtualization, as well as server virtualization. So at the fabric interconnect level, this is the switch of the system. You basically have physical interfaces. But those physical interfaces are really just providing infrastructure, physical connectivity for what are really logical virtual interfaces on the fabric interconnect, virtual fiber channel interfaces, virtual Ethernet interfaces. So the actual connectivity to a server logically is provided through these virtual interfaces, and because they're virtual, they can be moved, they can be dynamically changed, they can be brought up and torn down quickly. And with this virtual switch port, we also have obviously cables that connect to switch ports, and there are physical cables, of course, and these physical cables connecting to the physical switch ports are again really providing infrastructure for what really is logical and virtual cables. It's almost as if this physical cable is a conduit carrying virtual cables. And these virtual cables connect to adapters. They connect to virtual adapters on any given blade in the system. So you can have a single physical adapter, and this is adapter virtualization capability. So on the server you have a physical adapter, but that physical adapter is really just again providing physical infrastructure for what are really virtual adapters, multiple virtual adapters. Virtual fiber channel adapters, VHBAs, virtual Ethernet adapters, VNICs. And those virtual adapters connect with those virtual cables through the physical infrastructure to their virtual switch port on the fabric interconnect. And that adapter that's installed in the server really shows itself to the server as multiple adapters through standard PCIe virtualization. The server will simply scan the PCI bus and will find, based on how many virtual adapters have been provisioned, will see as if those adapters are physically plugged into the PCIe bus. So standard PCIe virtualization here. Now at the actual server level, you have the ability of stateless servers. So you have servers in the form of blade servers or rack mount servers that have obviously CPU, memory, and I/O. But the configuration of that server is not applied to the server itself. It's really carried in this service profile, and this service profile is held at the fabric interconnect in a database. It's basically an XML entry in a database that defines all of the settings of the server in terms of number of adapters. How many adapters are we going to have over here? Virtual adapters, the identity of those adapters, the firmware of the adapters, the firmware of the server, all of the settings of the server that you would typically configure on a physical machine, you're doing in this service profile. And that service profile, because it's abstracted from any physical machine, it's basically, like I said, an XML entry in a database. It can be applied to any blade server or any rack mount server, and that server that the service profile is applied to will carry or program itself with all of those settings. So that's really what provides the stateless capability of UCS. And in that service profile, again, remember, it defines the number of adapters. And because we define the number of adapters, the system will automatically provision these virtual cables to connect those virtual adapters to their virtual switch port. So all of that is automatically provisioned based on this single service profile here that you've created to define the service that you're attempting to stand up in the system. So because of the virtualization capabilities at every component of the system, you really have a unique capability to provide rapid provisioning of any service on any server, on any blade, through a system that is wired once with a physical architecture, but because of these virtualization capabilities, we're now able to dynamically provision services in a logical manner. Now remember, in the first video we talked about the physical architecture of UCS, what you actually see and what you're actually hooking up when you're initially implementing the system. And that's over here. You've got, the fabric interconnect, the switch with the switch ports and the cables going to the chassis, and each chassis got traces to an adapter and the blades. That's the physical architecture that you're connecting. And as we discussed earlier, or on the previous slide, that there's this virtualization capabilities that UCS provides at all levels of switches, cables, adapters, and servers. So now what we can do is we can take that virtualization capability and really tie that into a logical architecture, which really overlays or transposes itself on top of the physical architecture. So if you see in the middle of the screen here, we've got our virtual fiber channel and virtual Ethernet interfaces on the Fabric Interconnect with their virtual cables that run through the physical architecture to the virtual adapters, the virtual HBAs and virtual NICs that are on the physical adapters, which are associated with a service profile which happens to be running on a blade server. So this virtualization capabilities of servers, adapters, cables, and switches is transposed and overlaid onto the physical architecture of UCS. So what you really get at the end of the day is this here on the right side, this logical architecture, and the fabric extenders, the physical ports on the adapters, the physical adapter itself, the physical switch port on the UCS manager. All of that really looks like a conduit carrying these cables, these virtual cables, from the virtual HBAs or NICs up to their virtual switch ports on the Fabric Interconnect. So this is important because it provides, of course, dynamic provisioning, rapid provisioning, because everything is, we don't have to connect physical cables to stand up a service anymore. The physical cables connected at the very first implementation of the system, and now all of the actual standing up of servers is done through this virtualization, which can be done automatically through dynamic provisioning at UCS Manager. And when we look at how traffic flows through UCS, because we have this logical architecture overlaid on top of the physical, we're really going to be looking at this logical architecture in terms of virtual HBAs and virtual NICs connected up to and directly to the UCS manager through this conduit, this data center Ethernet conduit infrastructure that we've been able to provide. So in all the subsequent slides that we look at and how traffic is flowing and the various features of UCS, we're really going to be concerned with this logical architecture on the right side of the screen. And as a network designer and as a data center architect, that's really what you're going to be mainly concerned with as well.